So with this example, we're going to look at what pieces we have and kind of use the empirical rule to start out how we calculate these 95% confidence intervals. So here we're looking at this survey of 2,667 HR professionals and showed that 1,200 use social networking sites to research job applicants. So right here we have a sample size we're using, and then together they're describing this proportion of HR professionals that use social networking sites. So stating our sample proportion, so we have this sample proportion coming through of 1,200 out of 2,667, which should be a 0.4499. And then typically with these, we're always going to need the opposite of it too. So let's go ahead and grab Q hat, which is just 1 minus that value, which is 0.5501. For the standard error, using our formula up above, we're taking this square root and using that 0.4499 times 0.5501, and then dividing by our sample size of 2,667. So that's going to be 0.0096. There's our sample proportion. Here's our standard error that we're using. So we're going to draw how the sampling distribution model for p hat should look. And we're basing this on the assumption that right now, this is our best assumption for what's happening in the population. So first thing we should do is check our conditions that we talked about up above. So we should check independence, randomization, and our sample size. So for independence and randomization, we're just going to go ahead and say, yeah. For independence, the idea being that how one HR professional conducts these kind of this research is going to be independent on what other HR professionals do. So we'll have this independence. Randomization, they don't say a random sample, but we'll just kind of assume that they did a random sample when they sent out this survey. So then our sample size. This is where we need to take our sample size and multiply it with our value for p hat, and take our sample size and multiply it by our value for q. And we want to make sure that we get at least 10 out for each of these. So we calculate those are going to be more than 10. So our sample size is all good. So as soon as we pass those conditions, I know I have a bell-shaped curve. And drawing this out, so this is going to be a bell-shaped curve centered at 0.4499 with a standard error of 0.0096. For my sketch here, I'm going to simplify these numbers a little bit. Instead of 0.4499, I'm just going to use 0.45. And then moving this distance of a few standard errors in each direction, if I have the standard error of about 0.01, and this will be a 0.46, this will be a 0.47, this would be a 0.44, this would be a 0.43. So what we have right here is a distribution of p hat values. So we have this distribution of sample proportions from a sample of size 2,667. So that sample size is important because that's determining how the standard deviation or the standard error works in this case. And this is built around the idea that our value for our sample proportion, this 0.4499, that should be about equal to our population proportion. Right now, it's our best estimate. So, we have an idea of how things will spread if we have this proportion coming through. So based on our 68, 95, 99.7 rule, or you can also call it the empirical rule, based on this rule, where do you expect 95% of sampling distributions for p hat to fall? So remember our 95 rule said we go 2 standard deviations away. Go 2 standard deviations away to get that 95% out. So that would be, if we're starting here in the middle, going 2 standard errors up, 2 standard errors below, and that should capture about 95%. So, from our interval, we can see going down to 0.43 and up to 0.47. If we wanted to be more accurate, say we wanted to use these values right here, what we're technically doing is starting at that 0.4499 and subtracting away 2 of those standard errors to get down to that value. So it's like we're taking away 2 of those 0.0096 values, which would come to a 0.4307. And then for the upper bound, taking our value of 0.4499 and adding 2 of those standard errors. And that would come out to be a 0.4691. So we end up with this interval of values. We have this lower bound and upper bound. And upper bound for 95% of our samples that should be coming out based on this expected value of about 0.45. So making a sentence here, we would go with, we are about 95% confident that between 43.07% and 46.91%. And then what we can do is talk about this in terms of our population. So we were just looking at the sample of HR professionals. Now we can talk about all HR professionals. So between those percentages of all HR professionals, use social networking sites to research job applicants. So our 95% confidence comes from this idea of going 2 standard errors away. Because we went that distance, that links to 95%. What we want to keep in mind is that this is an estimate. Using that value for 2 right there is making this an estimate. So to get exactly 95% confidence, we actually need to fix this number a little bit. And that's what we do in the next video.